Hello friends, welcome to Quickfire Numerical Practice Series for GATE 2021. In this tutorial we'll talk about DIF-FFT, which is decimation in frequency fast Fourier transform. This is a method of taking your time domain signal into a Fourier domain signal, and the time domain signal should be in discrete format and the resultant Fourier domain signal will also be in the discrete format. So the objective here is to take this signal x of n into x of k, capital X of k, and we do that using this algorithm. Using this method, what you need to do is you need to draw 8 lines, each for one sample, and you need to write down the samples at the beginning of the line. But unlike DIF-FFT, you'll need to write down the samples in their usual order. You would not write them in the bit reversed format as we did in the DIF-FFT. Watch the previous video if you are a little confused about what a bit reversed order is, but you'll get the output in the bit reversed format. So this is super crucial because in numericals they might ask you to give the value of capital X of 5. So please understand the capital X of 5, incidentally it is featuring exactly next to X of 5, but if they ask you the value of capital X of 1, this is featuring in the 5th place. This is not featuring on the second place or the first place. So this is super crucial that your output will be obtained in the bit reversed order. And again, unlike in the case of DIF-FFT, we start with 2 groups and then we go on to 4 groups and then we go on to 8 groups. This is going to be exactly opposite. So you can draw these dots like this because we'll need 3 stages: stage 1, stage 2, stage 3. In DIF-FFT, we had the stage of 2 groups, 2 samples as stage 1, and the group of 4 samples as stage 2, and group of 8 samples as stage 3. But we are going to have this entire group of 8 samples in stage 1, out of which 4 will have weights and 4 will not. Just like this. We have second stage as 2 groups of 4 each, and the last stage will have 4 groups of 2 samples each. So if you study it in comparison to DIF-FFT, it will be very easy. And just like in the case of the butterfly diagram in DIF-FFT, this bottom line of the x is going to carry a multiplier of -1. So this is going to be -1, this is going to be -1. The bottom of every x will be a -1. And I've mentioned -1s here. And then please understand, you'll calculate the values here and then multiply the weights here to get the output. So this is going to be the output, and you'll multiply the weight here. So you'll get the output here, you'll multiply the weight and then send it to the next stage. The weights are not multiplied at the input stage here, so that is super crucial. Again, I would say it is exactly opposite to DIF-FFT, both in terms of the placement of the stages and in terms of the placement of the weights. So for example, you need to write down the values of the weights also. The values of the weights are the same. So the weights for stage number 1 is going to be 1, and then 0.707 minus 0.707 j, this is minus j, minus 0.707 minus 0.707 j. And in the second stage we had just 2 weights, so first is 1 and minus j, 1 and minus j, and the last stage has weights of 1. Now write down the values of x0 to x7. So this is 1, 2, 3, 4 and 4 and 3 and 2 and 1. So just send these values. If they go straight, they'll reach as it is. If they go down, they'll reach as it is. If they come up, they'll reach as it is. But if they go straight via these 4 paths, they'll be multiplied with -1. So with that in mind, you simply need to, for example, this is 1 coming straight, 4 coming from this way, 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. Now this is crucial. This 4 comes here with a multiplier of -1, and another thing coming here is 1. So -4 plus 1 gives me -3, and this is -1, this is 1, this is 3 because 4 is coming from this way and -1 is coming from this way, so this is 3. Now this 3 will get multiplied with this weight and will go on to the next stage. So that's the difference here in DIF-FFT, and you simply send the outputs after multiplying with the weights and multiplying with the multipliers appropriately. Send them, add them here, because these points are summing points. They sum up these 2 branches. So after summing up, you get the output of the second stage. Now again, crucial part is you get the output, you multiply them with weights and send it to the third stage. And in the third stage, it is not that difficult, because you simply get the output, and whatever output you get is your Fourier transformed signal, because even if you do not multiply it with 1, it is going to remain the same. The weights are 1, which is a blessing to us. So that's how you calculate everything here in DIF-FFT. And in the last stage, you get the values here. Just look at the values, pause this video, and if there is an error, just correct it, because do not look at the calculation part of this video, just look at the flow of how the numericals are solved. Now you write down x of k, but this of x of k is not in a proper order, you know that. So when you write down this x of k, please understand this 20 is sample number 0, but this 0 is sample number 4. So this is value of x of k at 4, and this third 0 is the value of x of k at 2, and so on and so forth. And another trick that you can remember to write down these in bit reversed order is that the difference of the second sample from the first sample is 4. So the second sample is 4 and it is 0, 4 minus 0 gives me 4, and then 6 minus 2 gives me 4, 5 minus 1 gives me 4, 7 minus 3 gives me 4. So every pair of bit reversed sample will have a difference of 4, and that's how you calculate DIF-FFT going from time domain to Fourier domain quickly, fastly. And I hope you liked this video. If you did, give it a thumbs up, subscribe to the channel, press that notification button so that you do not miss any video, because I'll post a video every day till the GATE examination is over, and I'll see you around. Take care. Bye bye.